Okay, so here's where we left off, and this would be the video Quadratics Part 3. Let me move on to the next slide. Here are some more notes for you. A couple things now that we need to work out. The discriminant. What is underneath the radical sign in the quadratic formula? That is the discriminant. So it's the b squared minus 4ac. That can tell us some important information. If my discriminant ends up being 0, so when I do the b squared minus 4ac, if I get 0 as an answer, think about it, I'm going to have like the opposite of b plus or minus the square root of 0 over 2a. If this is 0, that means that is all 0. And so if that's 0, I'm not adding or subtracting anything, I'm going to have just one x-intercept. So that might be something where, here's my graph, that might be something where my vertex lands right on the x-axis, and so I only have one x-intercept. Or maybe it opens down like that too, and I only have one x-intercept. So that is a possibility that you only have one x-intercept. Okay, I'm going to erase this picture so you can draw it if you want, but I'm going to erase it here. If the x value is, if the discriminant is positive, which is what happens most of the time, if it's positive, that's when we have two x-intercepts. It doesn't tell me what they are, but I know that I have two of them. And if it's negative, then I have no x-intercepts. So we have not done any of those because if the discriminant is negative, I'm going to end up with an imaginary number. And I told you that we wouldn't do any imaginary numbers, and we won't. But you still would be expected to tell me what would happen if the discriminant is negative. So if the discriminant is negative, my graph kind of looks like this. It's never going to cross the x-intercept. Or maybe it opens down. It never crosses the x-axis, So if the discriminant is negative, there will be no x-intercepts. If it's positive, exactly two x-intercepts. And if the discriminant is 0, then I will have only one x-intercept. Okay. The domain and range. I know if you saw on the slides that I showed you in the past, it had the domain and range written on it, but I didn't tell you what they were yet. The domain is all the x values, and that's part of chapter 4. The range is all your y values. So when it asks what is the domain and the range, to find the domain, it's all the possible x values. And almost always the domain is going to be all real numbers, because we can plug in any number for x and get an answer out. The only time that it wouldn't be is if you had a word problem and you had to think about if there was any values that you couldn't put in for x. For example, if it was a word problem talking about where x is the number of games sold, it wouldn't make sense for x to be negative, because we wouldn't sell a negative number of games. But most of the time, the domain is always just going to be all real numbers. The range is different. The range depends on the graph. So I'm going to graph this here. Hopefully it works. So if I have a graph and a vertex or a parabola that opens down, this is my vertex. This happens to be a maximum value. And so if that is a maximum value, my range would be any y values that are whatever that y value is and less. So if I have a maximum value, my range is y is less than or equal to whatever the y value is of my vertex. So you have to go back to what your vertex was. Let's just say this was the point 5,2. So that would be y is less than or equal to 2. If I had, if my parabola was opening up, this is a minimum value. Now my y values are this point and anything higher. So when I have a minimum, it's going to be y is greater than or equal to whatever the y value is. So if my vertex here, let's say, was the point -4, -3, my range would be y is greater than or equal to -3. So to get the range, it's important that you know whether the point is a maximum, the vertex is a maximum or minimum, and then you need to know the y value of the vertex, okay? Sometimes maybe a question will give you an equation of a parabola, and it'll say, find the range. You don't have to graph it. You don't have to find the x-intercepts. The only thing you need to do is find the vertex, and then look at the equation to see if it's going to open up or down. And all you need then is the y value. Okay? I'm going to erase this, so obviously you can pause it at any time and go back and fill that in. Okay, for the x-intercepts, sometimes, I don't really know why, but sometimes your book is going to say find the zeros or find the roots. That is the same thing as finding the x-intercepts. And we did that before. So to find the zeros or to find the roots of a quadratic equation, you're going to let the y value be 0, and you're going to either factor it, if possible, and solve it for x, or you're going to use the quadratic formula and solve it for x. Okay? Okay, so getting into some word problems. If all that I need is the minimum or maximum value, what is it you're trying to find? So if you've got a word problem, they give you a formula or they give you an equation, and it says what is the maximum profit when you sell so many games. All you need to do is find the vertex. You don't have to graph it, you don't have to find the x-intercepts. All you need to do is use that x equals negative b divided by 2a to find x, plug that in to find y. It's the only thing you have to do. Just make sure you read it, because sometimes it'll say what's the max or min, or sometimes it'll say what value will give you the maximum or minimum. That's when they're trying to find the x value. Okay? And we'll do one like that in a little bit. If they give you an equation, or I give you an equation and I ask you to graph it, you can always kind of go back to making a table of values. You would just need to make sure you have some negatives and positives. Make sure you plug them into your calculator, right? The only problem here is that it's hard to tell where the vertex is. In the easier ones, the vertex is pretty obvious. But on some of these now, the vertex isn't going to be so obvious, and so your graph might not really be right. So I would suggest, if you are asked to graph a quadratic equation, it's going to be a parabola. So the first thing you want to do is find the vertex using the formula. And then I would find the x and the y-intercepts. And then from there, I would use my my axis of symmetry and maybe plug in only 1 or 2 values to find other points. Okay, so you can kind of do a little combination there. All right, so if an equation or if a word problem asks you when the y equals 0. Now they usually won't say, what is this when y equals 0? It'll usually be something like, how long will it take before the ball hits the ground, or before a rocket ship hits the ground? Or maybe they'll give you the height that they want the rocket ship to be, where x is time and y is the height of the ball. So it might be something like that. So they're talking about basically when is the y value going to be 0? That's when you're looking for your x-intercepts. So as like normal, you're going to factor if possible, or you can always use the quadratic formula. And so if you get 2 answers, so if it asks you when the ball is going to hit the ground and there's 2 answers, how do you know if they are both right? Oh, what did I just do? Sorry, moved a page here. Here we go. So if there's 2 answers, do you always use both of them? No. If it's a word problem, you need to decide if both answers would make sense. For example, if the x values were the amount of games sold, it wouldn't make sense to have negative answers. So if you got a negative answer, you just wouldn't use that one. Okay? So if it's not a word problem, use both answers. If it is a word problem, just think about whether it would make sense to have both answers. Sometimes both answers are positive and you would use both. Sometimes not. All right, so I'm going to give you 2 examples here of using of word problems. These should be similar to what's in your book, but always, not always. I know there's going to be some that you're going to need the geometry formulas, but I think you could do that. So here we go. Model rocket is launched with initial velocity, v, of 200 feet per second, the height, h, in feet, and the rocket, t seconds after the launch is given. So here is my formula. H equals negative 16t squared plus v times t. How many seconds after the launch will the rocket be 300 feet above the ground? So first thing I'm going to do is use my formula and plug in what I know. H was the height in feet, and here it's saying 300 feet above the ground. So 300 equals negative 16t squared plus v is my velocity, my initial velocity, which is 200, and I don't know t. So in this first equation, our first example, they're asking me like how many seconds above the ground will it be a certain height. They're not asking me for the maximum. They're not asking me how high the rocket's going to go. They're just saying what's the height. So what I'm going to do is subtract 300 from both sides. And I get 0 equals negative 16 t squared plus 200 t minus 300. So now that looks just like the equations that we were solving in chapter 7. A lot bigger numbers, but that's okay because we have calculators to do the nasty work for us. So I'm going to use my quadratic formula here. T instead of x equals the opposite of b, so negative 200 plus or minus the square root of 200 squared minus 4 times negative 16 times negative 300 all over 2 times negative 16. So there's my quadratic formula. I might be able to factor this, but I'm not even going to try because the numbers are so big. Simplifying things, I get t equals negative 200 plus or minus. If I do all of that in my calculator, basically the discriminant. So if I do 200 squared minus 4 times negative 16 times negative 300, I end up with 20,800. And that is all over negative 32. Now I need to take the square root of 20,800. I'm going to kind of go over here. So I get t equals negative 200 plus the square root of 20,800 is 144.22, and I just rounded it, divided by negative 32. And t is negative 200 minus 144.22 divided by negative 32. I'm going to use a different color here. So when I do the math, negative 200 plus 144 divided by negative 32, I am going to get 1.74, 10.76. So I do have two answers. Would they both make sense? I think it would. If I think about how the graph would be, so I am launching a rocket. Time is 0 when I start, right? The rocket's going to go up in the air and it's going to come back down. It's asking when is it going to be 300 feet. Well, here's my 300 feet. There is 2 times that my rocket is going to be 300 feet high. So one of those is at 1.74 seconds, and the other time is at 10.76 seconds. So it would make sense to have 2 answers in this case, and those would be my 2 answers. If it asked me what the domain was, I would say all real numbers. If it asked me what the range was, I would need to find the vertex, and I'm not going to do that now. Okay? I'm going to stop this one again because of time.